right, let's look at number 6. For number 6, they ask us to find the average rate of change. Average rate of change is just slope, right? So slope is y2 minus y1 over x2 minus x1. So same slope formula is what we've always used. So you're going to need 2 points for that. This is not an ordered pair. See how it has brackets? These are your 2x values. It says the interval from 0 to 2. This is x1 and this is x2. So I've got 0 and I've got to find the y value that goes with that. And I've got 2 and I have to find the y value that goes with that. If you know x and you want to find y, you just plug into the function, right? So if I take 0 and I plug it into my function in the place of x, I would just get 0 squared plus 6, or 6. So there's my first ordered pair, 0, 6. And then if I take 2 and I plug that into the function, put 2 in the place of x, so 2 squared plus 6, 4 plus 6 is going to give me 10. So now I can say y2 minus y1, so 10 minus 6, over x2 minus x1, 2 minus 0. So 10 minus 6 is 4, and 2 minus 0 is 2, so 4 divided by 2 is going to give me 2. So that would be my average rate of change. All right, so then to determine whether a function is even, odd, or neither, let's start with algebraically. And the test every single time is I'm going to put a negative x in the place of x. If I get the exact same thing that I started with, it's even. If I get the exact opposite of what I started with, it's odd. Otherwise, it's neither. So you'll notice every single time I'm just putting a negative x in for x, negative x in for x, negative x in for x. So a negative to the fourth is positive, so that would be positive x to the fourth, minus a negative squared is positive, so negative x squared would be a positive x squared. So x to the fourth minus x squared. That is the exact same function that we started with. So when I get the same thing, it's even. All right, for this next one, if I put a negative x in for x, I can say a negative to the fifth is negative, so that'd be negative x to the fifth, so negative 2x to the fifth. And then a negative cubed is negative, so that'd be negative x cubed. So minus a negative x cubed is going to be plus x cubed. So I think that's the opposite of what it started with. It looks like it, but just to be on the safe side, let's factor a negative out of this. So if I take a negative out of 2x to the fifth, that would be a positive 2x to the fifth. And if I take a negative out of x cubed, that'd be a negative x cubed. And that makes it easy to see that, yes, it is the exact opposite of the function that I started with. So opposite is odd. All right, and then for the next one, if I put a negative x in for x, that'd be negative x squared plus 3 times negative x. So that would be positive x squared minus 3x. So it's not the same thing I started with. And for it to be the opposite, every sign has to change. This would have to be a negative x squared and a negative 3x. So since it's not the same or the opposite, then we would say it's neither. Looking at a graph, I think it's even easier to tell if they're even, odd, or neither. All right, so if you're looking at a graph and you can fold the graph on the y-axis and it folds on top of itself, it's even. If you can turn the graph upside down and it's the same thing upside down as it is right side up, then it's odd. Otherwise, it's neither. All right, so let's look at each of these. So for this guy, if I fold this on the y-axis, it does not fold on top of itself. I'd have to have like a piece over here and a piece over here. So it's not even. If I turn it upside down, though, it is the exact same picture upside down as it is right side up. That means it's symmetric to the origin, so that means that it is odd. All right, for this guy, I can fold it on the y-axis and it fold on top of itself. So you'll notice if I folded my piece of paper right here, they would fold on top of each other. So that's symmetric with respect to the y-axis, so that is even. All right, and then this last one, if I fold it on the y-axis, it doesn't fold on top of itself. I'd have to have like a piece over here and a piece over here, so it's not even. And if I turn it upside down, right now my y-intercept is at, I don't know, like a -2 or 3. If you turn it upside down, that y-intercept is at like a +2 or 3. So it is not the same thing upside down as it is right side up. So that is what a neither would look like. All right, for number 8, we want to take our toolkit functions from section 2.3, and we want to horizontally shift them, vertically shift them, reflect them, and stretch and shrink them. Okay, so remember that when you have a value that is attached to the x, that value cannot be subtracted over to the other side. It's stuck to the x. Any value subtracted from x is going to be a horizontal shift. If you have a value, though, that can be moved to the other side and subtracted or added to the other side, then that's being grouped with the y. That's going to be a vertical shift. Any value subtracted from y is a vertical shift. If you have a negative out in front of the entire function, that's going to cause a reflection in the x-axis. If your negative was just in front of the x and it was plugged into the function, that would be a reflection in the y-axis. And then if you have a number out in front of the function, that's going to cause a vertical stretch or shrink. That's the silly putty. So if it's a number greater than 1, it's going to make it taller and thinner, like twice as high as it was going before. And if it's a number between 0 and 1, that's a vertical shrink or a vertical compression. And so that's going to make it go like half as high or a third as high. It's going to make it shorter and squattier. Okay, so let's look at this first one. For this first one, we've got 4. So this 4 is attached to the x. It can't be moved to the other side, so that's a horizontal shift. And remember, it's what's being subtracted from x, or the opposite of this number. So that's a horizontal shift of -4. And then the 2 out in front is our vertical stretch by a factor of 2. So let's start with our beginning toolkit function that we are supposed to know what that looks like. And then a horizontal shift of -4. Negative numbers go backwards, positive numbers go forward. So that means we're going to go back 4 and draw the exact same graph. And then our vertical stretch just means that it's going to go twice as high. So if normally it was coming across here around 2, then the next one's going to come across around 4. It's just going to be twice as high. It doesn't have to be perfect, just so I can see you know what you're talking about. All right, then for the next one, this 2 can be moved to the other side. So you can see if I subtract that 2 to the other side, that'd be y minus 2 is equal to a negative absolute value of x. So that is a vertical shift, and what's being subtracted from y is a +2, or the opposite of -2 is +2. So that's a vertical shift of +2, and then the negative out in front of the entire function is causing a reflection in the x-axis. Now, order matters here. We said you would horizontally shift first, and then reflect, and then vertically shift. So the reflection has to come before the vertical shift. So here's our original function. So let's reflect that in the x-axis. So reflected is going to be right down here. And then a vertical shift of a +2. Positive numbers go up and negative numbers go down. So we're going to take this graph and we're just going to go up 1, 2 and draw the exact same graph, and that would be our final answer. All right, then for this next one, this 3 could be moved to the other side and grouped with the y. So that would be y plus 3. So the opposite of +3 is -3. That'd be a vertical shift of -3. And then this 1 is attached to the x. It can't be moved to the other side, so that's a horizontal shift. So what's being subtracted from x is 1, or the opposite of this is 1. So that's a horizontal shift of +1. So we're going to take our original toolkit function, y equals x squared, and we're going to go over a +1 to the right, and then we're going to go down -3. And so from right there, then we'll just draw the exact same graph, and that would be our final answer. All right, then for number 9, we have all kinds of things going on. So to begin with, they want us to do f plus g of x. Now, f plus g of x just means f of x plus g of x. So I'm going to take the two functions they gave me. F of x was 3x plus 2 plus g of x was 2x minus 1, and I'm just going to add those. So 3x and 2x is 5x, and 2 minus 1 is 1. All right, if instead of giving a letter there, they had given me a number there, all right, if f plus g of negative 1, well, if f plus g of x is f of x plus g of x, if I put a 1 right there, that'd be a 1 right there and a 1 right there. That'd be f of negative 1 and g of negative 1. So f of negative 1 literally just means take negative 1 and put it in place of x in this function. So put a negative 1 right there. So 3 times negative 1 is negative 3 plus 2 is where we get this negative 1 right here. All right, g of negative 1. That means put a negative 1 in the place of x in the g function. So if I put negative 1 in the place of x in the g function, that just means put a negative 1 right there. So 2 times negative 1 is negative 2. Minus 1 is going to give us negative 3. So negative 1 and negative 3 is going to give us that negative 4. All right, so then f minus g of x literally just means f of x minus g of x. So again, here's our f of x function, here's our g of x function. This time we're just going to subtract. So the same thing we did right here, only we're subtracting instead of adding. Now remember, when you subtract, you have to distribute that negative to everything that comes after it. So it's going to change every sign that comes after it. So that would be a negative 2x, and then negative times negative, that'd be a positive 1. And then we're combining like terms again. So 3x minus 2x is 1x, and 2 plus 1 is 3. All right, this guy, f times g of x, literally just means f of x times g of x. So let's FOIL that out. So 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 2 times 2x is positive 4x. And 2 times negative 1 is negative 2. So we'll combine these like terms, and that would give us a positive 1x. So there's f times g of x. All right, then for the next one, we had f divided by g of x. So that's just f of x divided by g of x. If there's anything that could simplify there, I would, but nothing there. I can't take out like a greatest common factor to simplify anything. All right, then for f, it asks me for the domain of that function that we just came up with. So remember, your domain is going to be all real numbers unless one of two things happens. You have a fraction or a radical. So our problem here is fraction. Every time you have a fraction, you're going to take your denominator and set it not equal to 0. Every time. So we set our denominator not equal to 0, so add the 1 to the other side, and then divide both sides by 2, and we'll get all real numbers except for 1/2. All right, so the way we write that in interval notation is negative infinity to positive infinity. That's all real numbers, but we have to leave out that 1/2 that's in the middle since we can't be equal to that. So we're going to go from negative infinity to 1/2, jump over the 1/2, and then go from 1/2 to infinity. And of course, we're using parentheses with the 1/2 because we can't be equal to it. And we always use parentheses with infinity and negative infinity. All right, look at G. Now, G and D are easy to confuse the way that the book writes them, because the way the book writes them, it writes like F and it puts like an O up here, F of G. I will not write it that way. I write it this way just to help avoid that confusion. So this is f times g of x. This is f of g of x. So start on the inside. Remember that g of x, they told us, was 2x minus 1. So let's replace g of x with what it's equal to, 2x minus 1. So now we have f of 2x minus 1. That means put 2x minus 1 in the place of x in the f function. So come up here to the f function, and we're going to put 2x minus 1 right there in the place of x. So that would be 3 times 2x minus 1 plus 2. 3 times 2x minus 1 plus 2. All right, then simplify that. So we'll distribute. 3 times 2x is 6x. 3 times negative 1 is negative 3 plus 2. The negative 3 and 2 would give us negative 1. So 6x minus 1.